Andy Walding here, and I'm going to talk about IPv4 subnetting. IPv4 is a 32-bit address, and if you think about this, it is 8 bits, 8 bits, 8 bits, and 8 bits. So if I know what to do with 8 of those bits, I know what to do with all 32. And that's what we're going to talk about. Okay, so I'll start here with a little reminder of that. There we go, 8 bits, 8 bits, 8 bits, and 8 bits. So to solve IPv4 subnetting, you need to understand what to do with 8 of the bits. So I'm going to add a little tool here to help us. I'll put it up here on the top right-hand side. So what we're going to have is 8 bits here, just like that. And if we think about an octal counter, the most significant bit is on the left-hand side, and the least significant bit is on the right-hand side. So on the right-hand side, the value of the bit, the least significant bit, is going to be 1. Then we will count by 2s, or actually multiply by 2s. So 2, 4, 8, 16, 32, 64, and 128. These are the value of the octal bits. That means if we were to represent a number, we would count the other way. So if we had a 1, for example, right here, its value would be 128. If we had 1, 1, the value would be 128 plus 64, or 192. If we had 1, 1, 1, you would add another 32 to that, so that would be 224. And this would continue. So 224 plus 16, 240, 248, 252, 254, and 255. That's when we have all the bits set to a 1, it would equal 255. Now this is the key tool that helps us to unlock IPv4 subnetting. Now when we think about IPv4 subnets, what we want to do is we want to understand exactly what the subnet address is, what the first usable address is, what the last usable address is, and what the broadcast address is of a given subnet. So if we think about this, let's just make a subnet, and we'll use a simple one. 192.168.1.15, and we will say /28. Now this means, the /28 means that we have a bit mask, and the bit mask is all the way out to the 28th bit out here. So it's all ones throughout the first 3 fields, finished with some number. And we don't exactly know what that is, and that's where our tool comes in to help us. So all ones, as we discovered, would be 255. So we would certainly have that in the first field. And since we're going all the way out to 28, which is way out here, the next number would be 255 as well, and the third number. But we don't know what the fourth number would be. So we have to think about it. There are 8 bits here. We've got 8, 16, 24, and 32 bits. So to go 28 bits, we've actually gone 4 bits in, which if you look here on the tool, 1, 2, 3, 4, would be a 240. And it's answered right there because we've done 1, 2, 3, 4 bits in. The tool helps to unlock that. So that is our, what we call mask, or subnet mask. Now from this, we need to figure out what a particular network this belongs to. And the way that we do this is we look at this 240 being on the 16-bit or 16 value. This means that we're counting by 16s. It means the subnets are 0, 16, and then you would add 16, 32, and then you would add 16 again, 48, etc. These are the subnetworks that mask of 255, 255, 255, 240 gives us. All right, so now let's look back at the original address, 192.168.1.15. If we think about that, that 15 falls right here. It falls right between the 0 and the 16. So therefore, we can say it's part of the 192.168.1.0 subnet. The first usable address is going to be 192.168.1.1. The last usable address has to do actually with the broadcast. The broadcast address is when all of the host bits here are set to 1. And if you think about adding those, 8 plus 4 plus 2 plus 1, the answer is 15. So 192.168.1.15 with this /28 mask is the broadcast address. And if we subtract 1 from that, 192.168.1.14 is the last actual usable address in the subnet. So what we've learned is that this is actually not a usable IP address. How fascinating is that? And we have fully analyzed this subnet using that tool to help us to unlock it. So let's do another one. Okay, so I've picked an address here. Let's this time do 10.10.10.48. And we will make it a /30 mask. Okay, so remember the very first thing we have to do is we have to solve that /30. If you think about it, that's all the way out here once again, out in that last octet of the 4 octets of the IPv4 address. But this time, it's all the way out at /30. Remember, this goes out to 32. So there's only 2 bits on this side, and on the other side, there are 6. That means we can look over here, 1, 2, 3, 4, 5, 6. It is a 255.255.255, and we see the 6th bit is 252. So that is the mask that is determined by the /30. We also see from our little tool that 252 lands on the 4 bit. So therefore, the subnets are every 4 addresses, 0, 4, 8, 12, 16, 20, 24, 28. You'll see why I have to keep going in just a second. 32, 36, 40, 44, and 48. Now, because that mask falls on the last octet, if you'll recall, that's the number that we're very interested in. And we see 48 falls all the way out here. In fact, it is one of those subnet addresses. So that is the subnet, 10.10.10.48. The first usable would be the next address, 10.10.10.49. The next subnet after that is +4, 52. So coming back, 1 would give us the broadcast address, 10.10.10.51. And the last usable address, back 1 again, .50. So there's only 2 usable addresses with the /30 mask. And once again, we have solved the entire subnet. Thanks to our tool, and thanks to understanding how to do this process. So hopefully with those 2 examples, this makes sense. Thanks.